Today I'll demonstrate how to find a vulnerability on an old router. Um, the router in question is a Tenda V300 DSL, which was basically headed for the trash. It was used. I've got the box for it as well, V300. Um, so I didn't know exactly which way I wanted to approach this, and I figured might as well start by having a look at the hardware. So that's what I did. I started taking it apart, which is why these antennas are all dangly. First thing I had to do was bust open the plastic shell, the top shell, using just a standard pry tool like this one. It had some clips, a few of which busted, but that's all right because I won't really be using this router for its intended purpose in the future anyways. Um, so the only really interesting thing that I found by examining the board were these four holes right here, which are labeled J4, and I'm assuming that they make up a UART interface, some kind of testing debugging interface, which I don't know if I'll even need to find the first vulnerability that I'd like to look at. Besides that, nothing very interesting. Going over the ports on the back, pretty standard setup. Um, uh, RJ11 jack for the WAN DSL connection, 4 RJ45 Ethernet connections for the LAN, power barrel jack, and a USB port as well. A lot of routers have a USB port on them for various types of purposes. I'm not sure what purpose this one serves. Could be handy in the future, but I've noticed on the box that they claim to support 3G or 4G dongle backups, so that could be where that is supposed to connect to. Um, so the truth is that I've already gone through the entire process of finding the vulnerability. I have successfully found one. So the rest of this video or series of videos, I don't know how I'll split it up, are going to be sort of semi-scripted. There's just so many ways to approach different parts of the investigation after the vulnerability. So I've tried to keep it concise and engaging at the same time. Um, and there are some things that I also discovered while redoing the whole process for the recording, which I hope will add some kind of dynamic element as well. Um, and that's basically it for the introduction. So in order to start, I'll need to connect the router to power, which is what I've done here. And I've also connected a regular Ethernet cable to one of the LAN ports on the back, the other end of which is connected to one of these Ethernet to USB external NIC adapters. And that will connect directly to my computer to form an ad hoc LAN with the router, which will allow me to browse to the web interface and start my software investigation. So all that said, let's power it on and see what happens. All right, so I've hooked up the router to my computer, powered it on, and now I just have to figure out how to connect to it. So in order to do that, I'll just pull up my computer's network adapter window. I've identified the correct adapter for my Ethernet to USB thing. Double clicked on that, hit this window to see that this window will tell me that I've connected successfully. There's certainly traffic passing through on whatever LAN this is between me and the router. And if I'll click on details, I'll be able to see the full details of the ad hoc LAN network that I've created. Specifically, I'll be able to see my computer's DHCP allocated IP address, as well as the router's IP address, and I assume that the web interface is hosted on that same IP address. That's how it usually works. So I will try connecting to it right now. And indeed, that was a correct assumption. Big surprise. Um, this is the login screen. I even get the admin credentials, which is really nice. I usually don't get that. And let's try logging in. So that worked just fine. And we're looking at the web interface for the router. We can even see in this specific model which port I'm connected to, which is pretty fun. One thing to note is since this is a second-hand router which was in use, all of the previous owner's ISP settings are displayed. So I will have to censor that. Um, and something to note, it's not exactly a very high impact security vulnerability. I don't know if you can even call it a vulnerability. More of an oversight on the vendor's part, which I think a lot of vendors nowadays don't fall down that hole, don't trip up on that, is these password fields. They don't just contain placeholder characters, they actually contain the actual passwords, which means that um, when the server side on the router is rendering this page for the client, it actually inserts the actual password. Even in this field for the wireless key, which is read-only, the data that's stored in this field is the actual Wi-Fi password of the previous owner, and it's actually really easy to uh, convert that into plain text, to extract the plain text from that field simply by using this JavaScript in the browser. That is the previous owner's Wi-Fi password in plain text. So there's no real point in ever transferring the password for anything out from the server to the client. I don't really think there's any scenario where that feature is needed. But I do think that this, well, actually, I do know that this firmware is quite old. And this company, Tenda, I haven't really heard of them. Um, I'm not really sure how security oriented they are, or at least how security oriented they were when this firmware was written. But probably, if I have to guess, not very security oriented because they were making mistakes like this. So in order to not have to censor out these details every time this page pops up, because we will be seeing a lot of it, I'm going to go ahead and factory reset the router to clear all the previous owner's data off of the router. And after that's done, we can continue on. Okay, great. So the router is all restored to factory defaults. Something funny that I forgot to note is that whenever my computer um, recognizes the LAN that it's on with this router, um, msn.com pops up in the browser, which is really funny. I'm guessing that's a feature of the router when it tries to do a connectivity check. So it kind of redirects the client to some kind of random website. And back when this firmware was written, I'm guessing that msn.com was what it used to be, which it isn't quite anymore. So that's pretty funny. I've probably driven up the traffic to msn.com quite a bit in the making of these videos. But anyway, let's go ahead and connect. Um, and this is much nicer, clean information, which isn't doesn't contain any personal data. Um, and what I did was I clicked on the advanced button to kind of dive into all the advanced settings into the actual meat of the router. Um, and what I'll try to do in this case is find, this applies to web hacking in general, not just to investigating IoT devices like this router. Um, so what I'd like to do is find any places that receive input in the hopes that I'll be able to manipulate that input in some way and achieve some kind of injection vulnerability. Um, and obviously, a command injection vulnerability is what we're aiming for because that will give us, in this case, the most relevant foothold on the device from the web interface. Although anything else is also more than welcome, I will be focusing on command injection. So before we get to that, I'll just have a look at this summary page with all the general information regarding the device. Um, I think the most relevant piece of information on here is the software version, um, which will come in handy later down the road. Um, this other stuff might also be useful, but I'll just uh, I'll just note that on the side and keep going for now. Diagnostics is where I'll want to start my search for interfaces for forms rather, that receive user input. And as we can see, what we found is a very standard set of diagnostic tools which most routers support. Um, the first one being ping test, then traceroute, which is kind of like a ping test but more pings, and NSLOOKUP, which is DNS based, obviously, to test the DNS configuration. So these two are for connectivity. Ping is for general connectivity, I'd say. Traceroute is for, I don't know, specific connectivity if you're trying to debug um, your routing table or something like that. And NSLOOKUP is for your DNS configuration, like I said. Um, yeah, this makes sense. Um, great. So let's have a look at the ping tool. Now, this firmware, like I said, was written a while ago. I know this because like I stated in the beginning, I've already gone through this entire process and I've done the research. And back then, I'm guessing, especially in the case of a company like Tenda, um, or security orientation, security mindset wasn't quite what it is today. Um, and the ping tool on routers was a classic place to find command injection vulnerabilities. This is because on the back end, usually what the software developers did, um, what they would do is receive the client input from here and then kind of construct a ping command using the user input and then pass that entire string off to a low-level C function such as one of the exec variants or the system function, and that would run that string as a command line program. So if, for example, uh, on the back end, the string that actually has to get executed, let's say the code looks something like this, where input is what I actually type, what I actually send to the server. So it's pretty obvious that unless some sanitation is done, some validation is done on my input, I can pretty freely manipulate the parameter that gets passed to the system function, um, and that will allow me to arbitrarily run uh, command line uh, programs, basically run code. So that is what we'll try to test for and see if we're able to achieve any results um, with that knowledge. So I'll try pinging something like localhost, simply because ping takes time. If there's a timeout or something like that, or usually these tools will send more than one ping to kind of gather statistics on packet loss, stuff like that. Um, so localhost should be a quick and easy um, test because it takes 0 time usually, and times 4 is still 0. But for some reason, it did take a bit of a while. Kind of weird, but it did work. So if I'm going back to the example that I gave, where the ping string is concatenated with my input, so I could try to break the input to the system function using some kind of bash arguments. I'm assuming that the server side is some kind of uh, Linux style operating system, so it's probably running bash or some kind of shell similar to bash. Um, and bash has a bunch of different characters which allow you to kind of control the flow of how the commands are run. So I'll just start off by trying a semicolon, which is supposed to terminate the previous command. It's supposed to just like separate between the previous command and another command which can come after. However, it does seem to be that the front end is checking for legitimate IP addresses or domain names. So obviously that is not either of those, and that's why I can't use that. I can try doing something like this. That's another bash character for a comment. In the event that there's some trailing, there's like another string which is concatenated to the end of my input. So this will kind of neutralize that, but it doesn't appear to be supported either. Could try just messing around with these as well. This one looks a bit more complicated. Looks like there's a whitelist for characters, and none of these really allow you to do anything special with bash. And this lookup is the same deal. Now, my suspicion when I see something like this is that the validation only happens on the client side, and we'll only really know for sure if that's the case once we're able to peek into the server side. So for the time being, let's just look at the client side. I'll just look through the sources, and it does look like this is where the validation happens in this function, which is probably the button callback for this button. This code here, this if statement is a validation check, this as well, and this as well. This is the condition that we were failing with using the special bash characters that I tried. And these two lines are where the actual request is sent using a just a standard JavaScript location set. It's kind of a weird way to do it, but then again, like I said, this firmware is pretty old, so it could be that that was the accepted way of doing things back when this was written. Um, in any event, this also tells me that there's no AJAX being used, um, which we'll also be able to see if I actually do give this tool something to check. So it sends it to the server. We can see that it takes some time because the request is pending, and then we get a response. Um, and the response is a full HTML document, which is just set as the main document. So that's how this form seems to be working. The only real thing that I've learned is that there is client-side validation, but I don't really know anything about the server. So what I'll try next is firing up Burp Suite and tunneling all my requests, my browser requests through there to try and bypass this JavaScript code. That'll also allow me to kind of play around with my payloads in an easier way. But another thing I could try is actually just deleting this check locally in my browser and trying to run that again. If I just give it a semicolon, send it. All right, so it actually does seem to be that there is no server-side validation because without that check, my semicolon did go through to the server, and we got this response. So let's look at Burp next up. Okay, so we got Burp running. Um, just gonna make sure that the proxy is listening on localhost port 8080, and this is so I can point my Chrome extension called proxy switch omega. I mean, I didn't write it, but I like using it. I just have to point it at the burp proxy using a profile I created, very basic. And then all I have to do to get the request to start flowing into burp is just telling it to send all my requests to burp. Simple as that. And we can already see a bunch of requests in the interceptor. So if we log in, we'll also get the login flow, which will be interesting later on. But for now, let's just head on back to where we left off. So now what I'd like to do is kind of sample all the requests that these tools issue in Burp so that I can start workshopping them. So I'll just create I'll create a ping request. There it is. Send it over to the repeater. Great. All right, now it's time for trace route. Get a request. Trace route. There we go. Get that in the repeater. Okay, now I've noticed that the router can only really handle one of these tools running in parallel. So now that that one's done, we could get the NS lookup. There we go. We'll just have all three of them. Great. And we might as well at this opportunity create a repeater tab for the login as well, just so we have that handy. Okay. So at this point, we could start playing around with this with these tools to see exactly what kind of effect we can achieve. So it looks like the semicolon just gives us network is unreachable, which is a bit bizarre because if I were to run a ping command with a semicolon on the end of it, that wouldn't really indicate that the network is unreachable per se. I mean, in this case, the network is specifically unreachable because the router isn't connected, but I would call this undefined behavior. This is not supposed to be happening just because a semicolon has been passed. Additionally, we've also noticed that if I pass a uh, hashtag symbol, a Twitter symbol, the output is empty, which is also undefined behavior. That shouldn't be happening. I mean, besides the fact that I should be getting some kind of error or getting blocked by some kind of sanitization mechanism saying that, that doesn't exist, it still shouldn't be giving me an empty output. I should be getting something. So the idea at this point really is to kind of sit and fuzz this out and play around with it and try to learn about the backend code just by examining all the different behaviors and all the edge cases, and maybe I'll be able to somehow escape the limitations that the server side is imposing on me, and I'll be able to achieve some kind of command injection. But the truth is I don't really want to do that, 'cause I mean, I like black boxing, it's great, but in this specific case there is an easier way, which I would rather go down that path. I think it would be a better use of my time, and that is through the firmware. Assuming that the firmware is publicly accessible through, just maybe the vendor's website, I could just download it and uh, examine the code, try to just read it, reverse engineer it. It might not be easy, but I think that it will be more fun than trying to smash my head against the wall of whatever is going on inside this black box. So then what I'll do is just copy this version string over to search and have a look at these results. So it looks like the vendor's website is popping up. We have a Turkish version, which I'm not too interested in, although it looks like the page might be in English, partially at least. Okay. This looks to be the same, just on the US version of the website. And this, well, it all looks to be pretty much the same. Um, all the patch notes are the same, and the version number is the same. Um, the only difference is though that I searched for 53015, and this firmware is 53016. So that is one minor version above what we're looking for, but it doesn't look like uh, we'll be able to find anything better. So it would appear that this firmware was last updated in 2018. I knew that it was old, so that should probably explain why um, a lot of the phenomena that we're experiencing, the security issues and bugs and all of that, that would explain it. Kind of playing devil's advocate on Tenda's behalf. I don't really know if they've improved since then, but it would make sense for them to be at that state in 2018. The patch note mentions some bugs being fixed. That's not too big of a deal, so long as they didn't fix any bugs that have to do with the diagnostic tools, because that's what I'm banking on finding in our version. So if they patch those bugs in this version, we might be out of luck, but it's the best thing we've got. So I will go ahead and download that firmware now. All right, so our zip file has downloaded successfully. Um, I will just mount it as a zip file simply because I don't really feel like extracting it at the moment. Although I will probably have to extract, um, I will probably have to extract parts of it out later from the zip file, but at the moment I don't really care to extract the contents of the zip to disk, so just mount it to memory as a straight as a zip file. So here's our the zip file contents are is this just this binary file which we can inspect using binwalk, of course. Okay, and we've got three sections. This looks pretty standard. We've got the router firmware header, which checks out. We've got squashfs file system, which probably contains the code that we're looking for, all the files. This will be the file system for the router, and we can also see that it was created in 2017, so that sounds about right. And we also have this LZMA compressed data, um, which I haven't investigated yet. I have some kind of suspicion as to what the significance of that file is, but at the moment I won't be focusing on it at all. Um, so what I will now do is extract these three sections out of the binary file. My bad. Great. Fantastic. So some symlinks seem to have failed. This might be interesting to look at. Okay, so it looks like some of these are probably caused by the fact that I had mounted the zip file to memory, but it also looks like there are a few other things. And basically, Binwalk is saving me from a headache, and any symlink that doesn't really resolve after the extraction is just set to dev null. Interestingly, it looks like etc password is supposed to be mapped to var password, but in our case, it's going to be mapped to dev null. I'm guessing it's because these symlinks are trying to point to my actual file system's root var password, which is really undesired. This should be relative to the extraction directory. So that's probably why binwalk is just overriding all those symlinks. I'm fine with that. So let's see what we've got. Okay, 7z file and squashfs root. So let us dive in and investigate. So the first step, um, in order to find the code that we're looking for, the code that handles our input, the traceroute tools backend, you could say, or the ping tools backend. The first step will be to search through this directory structure. It looks like we're indeed looking at some kind of Linux style system, classic root directory, and more specifically, it looks like we're dealing with a BusyBox. Makes perfect sense. So it's not exactly a regular Linux distribution. There are a lot of quirks that are unique to BusyBox, such as the fact that all of the bin directory, all the standard binaries that are built into the operating system are actually mapped to one big binary, just the same way as this Linux RC binary is mapped to bin BusyBox. So that shouldn't be too much of an issue because as far as this file system is concerned, the files are stored in the same way. Um, and we'll also have to look for them in the same way. So the first thing I'll do is try to search for this string, since this string gets substituted instead of the output that we're looking for. So supposing that we would be able to trigger some kind of command injection and output something back to the client from the server, it should appear here, but instead we're getting this string. So whatever code is setting this string is also probably handling our input. So that would be a good place to start. Um, so I'll just recursively grep for this string, starting at the root directory. Oh, my bad. Forgot to escape this guy. Okay, and we've got two hits. So the first one that stands out to me is this JavaScript file, which is in the webs directory. So I'm guessing that the webs directory contains it probably stands for web server, and it contains all the web resources, all the front-end resources, um, such as all these JavaScript files. This JS directory referenced here is probably this exact same JS directory under the webs directory. Um, and we can actually just have a look to see what exactly this file contains. And as a matter of fact, it looks exactly the same as the JavaScript that we were served in the browser. This must be the check that we deleted to check if there was a server-side validation. But besides that, there's nothing really interesting in this file, so it would be worth investigating this file. Now bin httpd, httpd tells me that this is an HTTP daemon. It's probably the server binary that actually listens for requests and handles routing and all that stuff. However, this string is apparently present inside of this binary, which is quite bizarre. I would expect this string to be to appear somewhere else in some kind of server-side scripting file, like a PHP file or something like that. But in fact, it's in the binary, which is quite strange. So we could start by running strings on the entire binary just to get a better idea of what exactly is in there. Um, we can see a few interesting things. First of which is this version of libc UC libc, which is an embedded alternative to the GNU libc, which I'm guessing this HTTPD has to dynamically load, so it has access to all the standard C functions. A lot of these functions, I'm guessing all these are functions. A lot of them start with CMS, and some of them also contain the name of the vendor, which is also very strange. This indicates to me that this binary was actually compiled by the vendor, and it's not some kind of standard HTTPD binary that comes from Apache or something like that. Um, and another thing to note is that this looks to be like this strn case CMP is a built-in uh, string function in the C standard library. Same with str and strlen, all these different strn copy, memset. But it looks as if they have compiled in their own variants or their own versions of all these standard functions, which is quite strange as well. There's a lot of weird stuff going on here. Um, so far, pretty good information. I see that the regular string functions are also present, so it's all very weird. Let's try searching for traceroute to see what we get. Okay, so the first hit, something weird, file open, traceroute test error. First of all, there's an initial string that we set out to search. So we've found it within the file, but we don't have any context. So it's hard to say why this is in the binary. This looks very interesting though. Trace result.txt. Um, and the second hit is actually very, very interesting. This appears to be the exact uh, command that is run on the server side when I send a request through the browser. I'm guessing that this %s format specifier is where my input gets substituted into this string. And the output of the traceroute function is then written out to this file that we saw up here. So this is all starting to come together. If I had to guess why the output has to be written out to a file, I would say that it's because the vendor is using the system C function to run this entire line of code, line of command line, whatever. And the system function doesn't allow you to capture the standard output of the subprocess that gets run. So it's easier to just write out the output to a file and then read it later. So that also could be what this fopen is all about. Additionally, it looks like ping is the same thing. There's the command that I'm guessing is run by the ping tool, and I'm guessing that if I'll search, oh, there it is, and its lookup is right there as well. So we've got the whole gang. Um, now now that I can see this, I could try to evaluate which one of these would be easiest to try and exploit a command injection vulnerability. And I would say that it's the traceroute uh, line, simply because the input is inserted at the end of the command right before it's written out into the output file. Whereas in the case of this NSLOOKUP file, there's another argument that comes after us in the line. So I'd have to neutralize that and then basically rewrite this redirection into the file. And the same goes for ping. So if that's the only parameter that I have to work by, I would just go straight for exploiting traceroute. And all this is assuming that the input gets doesn't get sanitized before it's passed into this line, into this command line. Well, anyway, I'm sure that there are many more interesting things in this file, but I don't really see any point in continuing to investigate it. I've got some pretty good leads. As an aside, I think it's worth mentioning that if I recursively grep for traceroute, I find quite a few results. The first of which is this HTML file, which I'm guessing is the actual file that gets served when I browse to the. This is like the back end of the traceroute tool that we saw in the browser. So if we try to read this file real quick, we'll encounter something very interesting. So it does indeed appear to be that this is the exact same file that we were working with earlier in Burp. Um, it's basically the same. The only difference being this line right over here, this empty status str. Over here, it looks like there's this weird syntax instead of the string that we receive here uh, in the client. So there is some kind of difference between what is actually stored on the disk over here and what the client actually receives. And the first time I saw this, I was pretty confused because um, I was expecting regular, a very common server-side scripting language to be present, such as PHP or ASP or something like that. And this does look like ASP. It's very similar to ASP, but it's only because of these tags that make me think of ASP. Nothing else in the entire code base, especially what's actually between the tags, makes me think that this is ASP. Um, and if I search for this, for example, um, on Google, if we try to, let's say, do something like that, HTML, we'll come across this embedded JavaScript templates, EJS. So I had initially thought that the EJ was part of the tag, but that's probably not the case. We're probably looking at something similar to this tool. I don't know how long EJS has been around and whether this is actually what we're looking at over here, but it's probably very similar. It looks like EJS supports all these different types of tags. The idea behind this tool being that you can you do your server-side scripting just using regular old JavaScript uh, like this in your inline in the HTML file, and then that has to get pre-processed and evaluated and rendered into full HTML before it's served back to the client, which is why we're seeing this here. And this is why we would see the regular traceroute output here as well. So basically what I'm saying is this line of code is what generates the traceroute output. It's what runs traceroute in some kind of way. Um, but it's quite weird trying to understand how this works because I don't see neither of these symbols defined in the scope. I don't know where these symbols are defined. I don't know where they come from. Trying to grep for that EJ get other function just yields all these results, which make sense. It looks like all the functions, all the different features that the front end exposes, they all use this weird function with weird parameters, which probably get passed on to whatever evaluates this code and runs the correct thing. We will, however, notice that the string is also present in the bin httpd file as well. And as a matter of fact, if we search for this entire string in Google, we'll come across the only hit on Google, on real Google. Actually, there are a few other hits, but none of them are very relevant. DuckDuckGo cuts us straight to the chase. It's a forum post written by someone who's in the exact same situation as us, where they've recognized that the code on the server, it's also some kind of DSL router. The code on the server contains this weird tag, and the generated output on the client contains actual data. So he's trying to understand, this person's trying to understand what's going on. Somebody was kind enough to quote a post from a different website, kind of explaining how this mechanism works in mini HTTPD, which is a very common HTTP server in the world of routers and that kind of thing. However, we're not running mini HTTPD, we're running micro HTTPD. The difference isn't very great. It's actually distributed by the same person. It's written by the same guy and distributed on the same website. This server only consists of 200 lines of code. I've looked at it. I've looked over them. I haven't really understood where exactly the template resolution happens, but I didn't look into it too deep, and it's a bit out of scope for this project, so I'm not gonna investigate micro HTTPD any further. It's just interesting to understand how this mechanism actually works. Um, this person also states that the server-side script functions are actually compiled into the binary of the HTTPD daemon. That's exactly what we were seeing in the strings output. And this also leads us on to this binary even more. What I understand from this is that the code that I'm looking for is in this binary. The function that actually handles the traceroute input is in that binary. Um, I'll just add another small note that this post goes on to describe potential vulnerabilities in with the system, and they're talking exactly about command injection in, for example, IP ping tester. So that's, yeah, basically exactly what we're trying to do. Um, I didn't invent the wheel, and this firmware is also very old. This post is even older. It's from 2012. Um, but yeah, it's still fun nonetheless, so I'll just keep going. And my next step will be investigating the HTTPD binary. All right, so Ghidra is up and running. I'm just going to drag in the HTTPD binary. I've gone through the trouble of transferring it out of the WSL environment into my regular Windows environment, and I'm just going to load it in. Everything looks to be fine in terms of the automatic recognition. And there we go. All right, so let's dive in. Let's analyze, of course. Let that run for a little bit. Great. So I think that the first place to start is to try and find uh, where that traceroute command is actually, where this string is actually used in the binary. So I'm just going to search for traceroute, and let's see where that takes us. Okay, looks like we got some good hits. We've actually found the exact string that we're looking for, as well as some other stuff that we've already encountered. It also looks as if Ghidra was able to extract the name of this function, CGI set traceroute. This function is actually surprisingly short. Let's try to understand what it does. Um, if I had to guess, I mean, so I was right in the assumption that the system function is used to run the command line. So that would make this argument to the function the command variable. So the command can be up to 1028 bytes long. which shouldn't be an issue for us. I don't expect to, I don't think I'll ever need more than that to run any kind of payload. It looks like there's some kind of logging here as well. But in the bottom line, it doesn't look like this function does very much besides run run our command and make sure that the output is stored in this file. So maybe we should look for this file to see where and even if the contents of it are read out. That was a bust. That too was a bust. Oh, okay. I was had the wrong radio button selected. Okay, so this is where we were, and I'm guessing this is where we would like to be. So let's head on down into, well, let's start over here. So we've got a function now that has a bit more meat to it. Right off the bat, this function actually deletes the output file. So it opens the output file in read mode, so this is good. This is exactly what we were hoping to find. And then at the end deletes it, so let's just try to understand what happens between them. If I had to guess, this is exactly where the magic happens. Indeed, there's a string that we had encountered in burp. So this is in fact the code, the exact point in the code where this string is generated and returned to the client. So that's good. That means that this if statement is not good for us. We don't want to be in this if statement. But let's kind of backtrack a little bit. We kind of got a bit ahead of ourselves. I can try commenting this, bad if statement. Okay, so we've got a bunch of variables over here. That's all fine. This just checks that the result file was opened successfully. That's another familiar string. And if it was opened successfully, the contents of it are read out in chunks of 0x100 bytes to 256 bytes. So this would have to be the read buffer, which is 256 bytes long in total. Yeah, makes sense. We already knew that. And then for every chunk that's read, the while loop will ensure that the return value isn't null. And then they use their weird version of strcat, I'm assuming, to concatenate the read buffer over to this variable. Which I'm guessing is the output buffer, since this same variable is used to store this string that we definitely see in the client. So let's call this the output buffer. Now the regular strcat function receives only two parameters, the source and destination. I don't exactly remember their order. And they've added these two parameters as well. It looks like their version of strlen also adds an extra two parameters, and strcat again. So I'm guessing that this is the name of this function. So we might as well just do that. And I'm guessing that this string is used for logging. So this is kind of their way of kind of monkey patching or hooking into all the standard C functions to get logging. It's just a guess. And then this last parameter looks like it gets bigger by 2 or 3 every time. No idea what that does. Don't really care though. So let's just keep going. So the output buffer accumulates the contents of the trace route result. And now we reach the bad if statement. So IVAR1 in this case will be the, okay, so what, I skipped over this. This line checks the length, runs strlen on the output buffer. So this would be the length, let's just call it length. And the bad if statement basically just checks to see if the length is less than 0x65, which is 101. And if the buffer is shorter than that, we receive our error message. So this code is badly written because this check seems to be completely arbitrary. I'm guessing that they checked and found out that traceroute usually is never shorter than 101 characters unless there is no network available. In that case, you might get a shorter error message. However, this masks out other potential issues such as command injection vulnerability or a million other things that could screw up the length of the output. So I wouldn't write this code the same way, but this is how they chose to do it. So in theory, if I was able to pass a payload that is longer than 101 characters, we might be able to skip out of this if statement into the else block. And the else block looks like they substitute all the break lines with tilde characters. And it looks like that's just it. And then the output buffer is concatenated to one of the parameters. And I'm guessing that's some way to get it to return back to the client. So let's try out this theory and see if we're in the right direction. So actually, before I do that, we could try to kind of understand the different behaviors that we were seeing. So when I sent a semicolon, what actually happened to the original string that we were looking at is a semicolon was just being written here, and nothing was being written. Basically, an empty string was written out to this file. I don't even know if that it's valid bash syntax. It could be that nothing was written out to the file. In any event, the file didn't contain enough content to pass this check, and that's why we received this error. And when I put in a pound symbol, the hashtag, that actually just commented out the rest of the line. So the file wasn't created to begin with. So the trace route ran just fine, but the output wasn't written to the file. It was probably just spewed out into the standard output and into the trash. So that's why when I use a hashtag symbol, oh, the cookie expired. When I use a hashtag, we get an empty output. So it's all starting to make sense. It also tells me that this firmware is still relevant to our investigation, even though it's not the exact same version. Okay, so now let's try checking the length. Echo, let's try just spamming a bunch of A's, seeing where that gets us. I don't know if that's enough. Let's try. Great, that worked perfectly. We got okay, and then we got all our A's. No trace route output anywhere in sight. So in theory, I should be able to arbitrarily execute commands now. That's the first proof of concept that we've got for a command injection vulnerability. So let's try to cat etc password and see if that works. Hey, it does. And it also doesn't output the echoes because I'm guessing that the only thing that will get written out into the file is the output of the last command, because of the operator precedence in bash. So maybe we don't even need all this echo, assuming that the output of this command is longer than 101 characters. And it is. So if you ask me, this looks like a successful command injection vulnerability found in this router. The next step will be to write a small exploit script to work on this, to make it easier to execute code on the router, and I'll get on that. So I'm done writing the exploit script, and this is what it looks like. It's not very long, um, just just over 50 lines, and it did take a bit longer to write than I thought, simply because I had initially tried going down the NSLOOKUP route. I tried exploiting command injection on NSLOOKUP. It did work. It's also vulnerable to command injection, but there are some dumb limitations on that function on the server side. For example, it doesn't check the length of the output, but it does check to see if the substring name exists in the output. So I have to echo that myself, and it'll also appear in the output. I can't parse it out using regex just fine, but the main issue with the NSLOOKUP tool is that the output buffer is too small. It's like 128 bytes or something. Well, I don't remember how long it was, but it was way too short for most commands. Like running ls la on the root directory um, caused issues on the router. I'm assuming that it got as bad as some kind of buffer overflow because the router kind of, I don't know, kind of shut down for a little bit um, after I triggered that issue. So I'm assuming that that has to do with that. But in any case, it doesn't really matter. I might investigate that separately. The bottom line is that it's not good for the purposes of my exploit. So I did just end up using the traceroute function. Um, I did have to generate padding, just like I did in Burp. Um, and since I don't know how long the output of the command is, I always write out 102 A's. Um, that means that for longer commands, it's going to be the length of the output will be 102 plus however many characters are in the output, and that could be an issue because the buffer size here is also finite. It's basically 3072, so it is possible to reach this limitation, but NSLOOKUP's buffer was much smaller, so this is preferable to that. Some parsing is done using regex as well, very simple, and the tildes are replaced back to /ns just to get the nice output. And if I run this now, I forgot to mention that the script also logs in using the credentials, and that was basically done. I was able to implement that just by analyzing this login request, looking at the server-side code that issues the JavaScript code that issues this request. The username and password that you enter on the login page are hashed into MD5 and sent over the wire. This session key is some kind of random number which doesn't seem to do anything. Verify code is always empty. And that's basically it. So I did kind of like how they hash the passwords before they send them. It's unfortunate that they used MD5, but 2018, I guess it's okay to have used that and not something more secure like SHA-1. Another benefit of having the hashing is that the admin interface is served over HTTP and not HTTPS, so there is some basic security implemented, but not enough, as we have seen. So let's try running some commands now. Who am I? Returns nothing, that's fine. Working directory is root, and this is the directory structure of the root directory, and it looks identical to what we extracted from the firmware that we downloaded. The only exception is that the TMP symlink is actually working. We can, of course, check out what's going on in the password file. We've got 4 users. That'll be interesting to investigate further down the line. Maybe have a look at the process list as well. Yeah, so I guess that's basically it. This is the proof of concept. This isn't the end of the road, I think, because just finding the command injection is really where everything starts. This enables you to really start investigating the router live, like I'm doing over here. Um, and yeah, I guess that's really it. Um, I will mention that I had initially thought that this investigation will take me down the hardware path. I was already preparing to start pulling chips off the board to extract the firmware from there, or maybe hook into that JTAG interface that I showed in the beginning. I might still get to that, but this way was much easier. I could bypass all that and still achieve the same result. Um, since I don't have since I don't have any specific goal in mind with this project, I might experiment with all that regardless. Um, and besides all that, I really hope that all these videos wasn't too rough around the edges. I'm still trying different things out to see how to make this work. I don't know if I'll continue doing this or not, but yeah, just thought I would share the process and talk through it and demonstrate how one could achieve this result, finding command injection vulnerability, which is pretty serious by itself, but I'm sure that it's a stepping stone to more serious impacts, a higher level impact on a router. So thank you very much, and that's it.